We have Lynn joining us now from Agile Data, and he's going to talk about how I learned to stop worrying and evolve with on-demand schemas. And so again, we're gonna combine the idea. It's great if you have the tools. It also helps if you know what to do with them. Lynn.
Thank you. I have a clicker. Let's see what happens if I click it.
Be formless, shapeless, like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash. Be water, my friend.
So I like Kung Fu movies. And Bruce Lee is obviously the godfather of Kung Fu movies. And he was also a fantastic martial artist. If you ever pay attention to what Bruce Lee did, he invented an entirely new style. I'm just getting in front of the mics here. An entirely new style of martial arts that he called Jeet Kune Do, and it was branched off of Wing Chun, and you can geek out on it forever. But this idea of being like water that he had is pretty interesting to me from just a technology perspective. If you want to learn more about Kung Fu, there's a really good instructional video that's on YouTube. This video came out recently by some Swedish guys, and if you really want to learn kind of some of the core principles, I'm being incredibly sarcastic. This movie is about 30 minutes long, and it's like the best 80s action flick you've ever put together. So if you haven't seen this, I got to plug this because it was on Kickstarter, and you got to do that. But okay, joking aside, water is this thing that Bruce Lee talked about, and water is this fantastic metaphor for martial arts. What you can do with water is you can move it out of the way. You can push at water, and it yields. Water is flexible. It's fluid, literally. It moves out of the way. But water can also be incredibly powerful. Water can do immense damage on its way from high point to low point as it's flowing somewhere. If you get in the way of water that's acting like this, you get in trouble. In that sense, water demonstrates great agility. Water can flow from any point to the lowest point. It might get stopped up and contained in a cup, as Bruce Lee says, but when you try to push it, if you aren't containing it in its entirety, it will just flow around you. And this is very interesting when you start to think about software development. This idea of agility that we've probably learned quite a bit about over the last 14 years. When the Agile Manifesto was published, I had only just started writing software, so I'm relatively young. But between then and today, the influence that the idea of Agile development has had on our industry has been just huge. Probably everyone in this room is doing some variety of an Agile process, right? They've spawned so many different varieties over the years that you either can focus on Scrum or XP or Kanban or all sorts of different things, or lean operations, and now that's spun off into DevOps. There's such an influence that this flexibility, this focus on flexibility and being lowercase a Agile has had on our industry. You know, they all started with these 12 principles that I'm not going to read to you. You can read them if you want. But some of the really important ones are that you want to be continuously releasing, right? You want to focus on self-organization. And most importantly, you want to embrace change, right? Change is always happening, and it's up to you to react to it. There's a really well-known study that came out that talks about just how aggressively the mobile market has expanded, and when you throw IoT in that, the demand for changing application circumstances and the way we change this to the way we process data is increasing at an ever faster pace. You know, Gartner basically says that the increase in mobile, and this was just last year actually, this isn't that long ago. You know, mobile's been doing the mobile thing for quite a while, but the increase in mobile paired with the stuff that's happening in the Internet of Things is forcing organizations to be even more agile than they were before, or if they were kind of late to the game, then they have to really up their game on this. Why does this have anything to do with data? You know, I'm kind of preaching to the choir, I hope, in terms of what's up with Agile. We've made all this progress, right? but there's kind of like a wrench in the gears. There's something that's like gumming up the works, and that's the database. The database gets in our way. If you guys have seen this XKCD, this is the textbook, literally SQL injection attack. Why is this pertinent? Because the application just nuked a data structure. It mutated the database in production, which A is a huge configuration management fail. You don't want to allow that kind of statement to even run, but it's also a software development fail. You don't send clear text without binding it to statements and that sort of thing. So lots of lessons to be learned there. But the database is really, it has such power over us that you can do this. You can screw up a production system if you build errors into it so easily. There's this guy named Martin Fowler who is tremendously influential in the Java and Ruby software development spaces, that on his website basically says that changing the database late in any given application development, even if you're using an Agile process, can cause widespread breakages in your software. That's like while you're still developing it. But if you're in production, he has something else to say, which is that you got to do this painful data migration. In the case of a database, like a migration is this thing where you had data shaped one way, and then you realize that that wasn't good for this next use case we have, this new feature we had, and you want to shape it differently. That's a painful data migration problem. And there's a whole bunch of tools that have come out to solve that. But before the tools come up, it's very frustrating to do that migration, to do that without tools, or to do that without a system that handles that, because databases don't do it. It can be so frustrating. It's like kind of watching your Windows machine crash and wanting to just throw it out the window and give up this whole software development thing and like go do underwater basket weaving. For me, I got very excited with some of the early tools that came out around database processing. Some of the things that allowed you to do schema migration. And they had a lot in common with a really old thing that Charles Darwin said, which is, in biology, it's the species that are the most able to adapt to changes in the environment or changes in the competitive environment that are able to survive. And in business, there's probably 100 books that have this quote in them. The most competitive businesses are also the ones that are able to adapt to change fastest. So the database, the one thing that holds up our Agile development processes, the database must also be Agile. Most of our relational databases aren't. Some of our NoSQL databases are pretty close. But you have to be Agile with your data. What makes a database Agile? Rhetorical question, but it's not just the tools. It's not these fabulous tools we have to do schema migration, painful schema migration. Right? These ease the pain by letting you build changes to the structure of your data into the source code that uses that database. They're very helpful. Tools like Liquibase have been around since, I believe, 2006, 2007. Very influential. Some of those use painful things like XML. Some of them are just raw SQL that you run. Some of them are integrated into Ruby like Rails. But they all are these adaptations around what's underlying, which is the database, which doesn't have this flexibility built into it. The structures are rigid. You stick things in there, they're stuck. So if it's not just this tooling that lets you change the structures, change the tables, add views, do things like that, what is it that really makes a database Agile? Right? The first thing is that anybody that touches the data, everybody that touches the data, must have a simple experience, because this is already a hard enough world. If you've seen that big data landscape slide that those guys put out, you need to get out the magnifying glass to sort out the variety of tools and all these special purpose things. You got to go hire somebody like Cloudera just to help you figure that out, even to get started on a big data initiative. So if the analysts and the operations people and the DBAs and the decision makers don't just get what's going on with your data, you're kind of starting off handicapped. So the first thing for any data effort is to focus on simplicity. And that's really hard as a developer. It's hard for me to do. I always want to add that other thing, or wouldn't it be cool if it also did this? Right? The answer usually is no. It shouldn't also do that. Right? Tell me why. Prove it. Show me the list of users that really want this and that's also compatible with our business strategy. This goes without saying, but any database that purports to be Agile must also be scalable. This is a fact of the day that we live in, that data has grown far beyond the size of a single machine. You have to be able to use multiple machines. If they're commodity machines as well, that's great, but even very large machines will run into cache issues, or you won't be able to fit all the data you want or all the history you want on it. You have to start making trade-offs. So we're in a multi-machine, multi-processor, concurrent world. A database needs to be aware of that and be able to scale out in response to the change in load. And my favorite topic is that data is basically an expression of life. It's a model. When you think about data, it is a snapshot of a point in time in our lives, right? You look at your bank account balance has some number in it. You think, that's what my bank has. And then you go somewhere else, and behind the scenes, an automatic transaction occurs that reduces your bank account balance. But to you, you still think the data's the same. You still think that number is whatever it was. But now it's a little lower in reality. The problem is there's really no such thing as the present. It's just a continuous stream of changes to that number, the bank account balance number in that database. It's a stream of transactions. And so any database needs to think about data not as this snapshot of the world that you've just stuck somewhere, but really as a stream of continuous changes that you then apply functions to get your answers. So it's very relevant to the way functional programming works, but this is a tremendously important concept to think about when you're trying to figure out, how do I store this? Which database do I pick? Do I grab a NoSQL database? Do I grab a message queuing database? Do I use something like Apache Kafka? Kafka is very streaming oriented, and it's a technology that I'm really excited about. It came out of LinkedIn. If you guys haven't looked at Apache Kafka, I recommend you take a look at it. It's very exciting. Kafka will get the data from point A to point B, but it won't apply the processing to that stream of data. That's up to you to write that code. And so many of us have, and there's all these tools that are coming out, my tool as well, Agile Data, that helps solve those problems where you can structure computation in a streaming fashion, treating data not as this static repository that goes in, but really as mutations of continuous streams of data that you can look at in different ways. So on the front end, when you're adding stuff to your database, you can also on the back end do analytics that allow you to do leaderboards and dashboards and downstream continuous analytics that we often add to our systems after they're successful. And when you try to add it to a system after it's successful, and you're sitting there on a relational database like SQL Server, Postgres, or MySQL, or any of those, you've got that high activity table where all these writes are coming in. And then you're like, well, we want to query that and make a real-time dashboard out of that. And so the only way to do that is to add some new index to some column, because you need to group by that column, and then you want to sort by that. And that index, just by adding that to the table, slows down the insert performance. It slows down the user experience. So the only other way to do that is to do some sort of replication-based thing or some periodic job that then recomputes these aggregates and then stores them in another table. But there's still these static snapshots. You're making these tough trades, but if you could look at the data as just a continuous stream and get the answers you wanted out of it, you'd actually be in pretty good shape. I borrowed this slide from one of our board members who has like the best slide presentation style ever. Everything is handwritten. It's just like a whiteboard. It's fantastic. So I can't claim credit for this. He's actually speaking. He's now with one of our customers, but he's speaking on Wednesday morning, I believe. Pretty early. His name's Corey Isaacson. I recommend you check out his session. But the idea here is you treat data as a stream, and you have continuous queries on that stream that answer those questions. And if you need to change those queries, they can just tap into the existing stream and produce new answers for you without affecting the input, the data input. And the way you do that should be with SQL, because SQL is the lingua franca of the data industry. SQL is the thing you probably first touched if you got into this whole industry without going through a CS program. If you went through a CS program, you didn't touch it until senior year. But if you started as an analyst, or you are an analyst now, or you in any way want to get an answer from the database and you don't want to write Java or C or .NET, you're going to write it in SQL. That's what we all understand. That's what we can work with. Every one of these big data tools, which I'm a huge fan of, require enormous investment of effort and time to upskill ourselves to learning a functional programming paradigm in Clojure or learning a new language like Scala. As awesome as they are, it is an investment, and you have to do that at an organizational level and decide we're going to change the way we write software because this tool does so. If you could express your data computation in SQL, you've really simplified that, and you've made it accessible across your organization, really lightening the burden on the developers, lightening the burden on DBAs, and making the operations of life a lot more simple because you're working with what you already know. So how would you do all that? This is a pretty simple concept, but just quick show of hands, who has used Hadoop or has even looked at it before? Okay, that is a really good showing. Okay, Hadoop is based on this concept. Hadoop says, I've got data, I've distributed across tons of servers, possibly thousands, and I want to move my computation to that data rather than moving the data to my computation, which is kind of the way we've been building apps since the 50s or 60s, right? Because the data was small. But now it's so big, you can't take the data off of the disk to the processor. You have to put a processor next to the data, number one. Then you have to send your specific computation to the data. This works very well in Hadoop. It's a batch-oriented process, right? So even if you use something awesome like Apache Spark that does it very quickly, it's still a batch-oriented process. You compute how am I going to execute this batch, and then you send the batch out to the cluster to be run next to the data. Right? We've got a tool at Agile Data that does something quite similar. Right? I'm going to try to keep this not too pitchy, but I want to illustrate the concepts. We take a stream of data and we partition it across a number of views. And then you apply your transformations, your SQL, to that in a parallel manner. So what you get is you get this local execution of data of, in this case, a very simple transformation that maybe people has more than just A and B in it, this people view, vPeople. But there could be hundreds or thousands of partitions here and one select statement that is translated onto that cluster. Right? This allows you to focus on what you know and not worry about the details of the execution. Then what you do is you treat these views just like point-in-time snapshots of what is underlying a continuous data stream. You can custom partition that as well, so you could split that up according to different logic. That's fairly advanced, and hopefully we don't even have to deal with that usually, because most partitioning problems aren't that big of a deal. But as soon as you're in a parallel world, if you have data on these 4 machines, and you need to get some of the data onto these 2 other machines in order to compute something or compare them or sort them or compute some aggregate, that's called a shuffle, and it's one of the most expensive things in big data. It's moving data from one machine to another machine or several machines. And so you want to be cognizant of that. It's one of the things in SQL that you can't necessarily get away from, and you do have to pay attention to, but at least you can make it simple and not have to expose Java to everyone in your organization, as awesome as Java may be. So if you think about what is a stream and what is a snapshot of a stream, it's a lot like a movie reel. You know, a movie reel is X frames per second, right? And we're on our way up to 60 frames per second video now as a standard. It's 60 pictures of reality a second, right? You're taking what I'm seeing right now, what you're seeing right now. That's a continuous thing that everyone's brain is experiencing right now. You're not taking pictures in your head. It's this kind of continuous process that one day we'll have computers that can do something quite similar. But right now, it's a serial process that each CPU core knows how to deal with. It takes pictures and processes things atomically in these quantized chunks. But it's a tremendously powerful metaphor to talk about data as kind of like a movie reel. Little bits of snapshots. It's like this now. It's like this now. It's like this now. And we've been doing that in relational databases for a very long time. Relational databases actually have this streaming model built into them that they don't really do anything with besides just play the movie. The replication log in almost any relational database is structured as a series of binary log files. You have a master database and you have a slave database. You write data into the master, and then whatever happened there goes into the movie reel and then gets shipped over to the slave to be replayed. And that's kind of what you call a replicated state machine. You have a state machine on the master. You've mutated that state by applying, I don't know, insert statements or update statements, and then you've shipped that over to that slave to be reproduced primarily so that if the master goes away, the slave's fine. But if you zoom in on that, what are these binary log files? They're really just those mutations. They're an insert statement that creates a new employee, right? There's an update statement that sets the salary to $1 million, right? There's just a bunch of stuff that mutates that state and then gets replayed. And it's important to realize that this is a fairly mature technology. Databases do this. They just don't utilize it to its full potential. Except for perhaps something like Kafka, which I was talking about before, which exposes this and brings it to the forefront. So logs allow you to do arbitrary stream computation. This is a newish concept that's new to the big data world. We don't have a lock on the idea, but it's definitely something to think about, which is think about your data as logs. Data comes in, it's a stream of events, a stream of things. You apply a function, a transformation of some sort to it that's specified via SQL, and you get another log out the door. And that log can equally go super fast to disk, super fast to memory, optimized for inter-log communication or inter-stream communication, or super fast to network if necessary to go to another machine. It's a very nice way to think about processing data. You have a log in, you have a continuous function that you apply to that, and you have a log out. Logs get you reliability as well. This is basically the replication that I just talked about. If you have a partitioned set of streams, and for any given topic, you also have reads, followers that follow that leader. If that leader goes down, you know, in this case we use a technology called Zookeeper, but there's several other kind of quorum decision management frameworks to do this. We'll notice partition 0 example master's down, the leader's down. Let's just tell all the clients, don't get your data here anymore. Go to this follower, which is always up to date. Right? And what you do is you manage that replication. So you know, did the write to the leader get to the follower? Did it get there in time? By doing so, you're able to have these self-healing systems that are able to respond to change and respond to failure without operational situations. And you can do that automatically. It can actually fail over automatically. At my last company, we used a product that my current company now makes, which does this very well to avoid operational downtime for years. It was a fantastic product that allowed us to upgrade our database on the fly, upgrading the schema behind the scenes, and then switching who is the leader without the end user even noticing. It was very nice. So logs get you this reliability, but with that reliability comes so much power for your software system. You can actually be much more flexible with your data just by utilizing something like this. So putting it all together, like what does it take to have an Agile database? You need to be able to cluster data across a number of machines. You need to be able to do distributed stream processing, which means applying functions like select statements, or specialized functions, writing your own in various languages, like Java, or Clojure, or C++, or C#. Apply that to a continuous stream of logs that is managed across that cluster for you. You need to pair that with high-performance embedded storage, or you need to plug that into third-party data stores when you want to get out of this new universe you've made, this Agile database universe you've made, and you want to interact with your existing data stores like your SQL servers and your Oracles. You want to be able to adapt to that in as clean of a fashion as you can, where you've bridged the impedance mismatch gap where your relational database treats this stuff as static data, but your cluster's treating this like streams. That's the kind of bridge you're going to go connect to the real world. You want those streams to be dumped cleanly into that third-party data store so that what it thinks is reality, what it thinks is the newest part of the world, the current view of the world, is as close as you can get it. And if you already think of data as a stream, you're basically just playing the latest stuff into that external system. So you can play nice with other systems, be they SQL or NoSQL. You need to allow pluggability in something like this. If you build something that only works with SQL, either it has to do everything or you're in trouble, right? And usually a system's not going to be able to do everything. So you need the ability to plug your own functionality into this. And that, at least for us, what we found is that user-defined functions is the best way to do that. If we still let you express your computation in SQL, and you can chain SQL, you can change different streams together, you can derive new views on data, sometimes the functions that come out of the box in any database aren't enough, and you need to add something like a specialized histogram calculation function, or a recommender function that you want to apply to a stream of data that's happening continuously. You need an API, you need a set of primitives that allow users, and when I say users, I mean developers, to write new functionality into the database in a clean way. What we found is the cleanest way to do that is to still express the functions as SQL and then implement them in your language of choice, like Java or C# or something like that. And the only way to make that easy is to use advanced build time tools to make that simple for the developer, keeping in mind with this idea of simplicity. The tool needs to handle this for you, where it just gives you a simple Java interface or a simple C# interface to implement. And by doing so, you can deploy that into the cluster. And then the cluster can run it for you on terabytes of data. Well, the instant you do that, the instant you're uploading code into your database, now you've got a versioning problem, right? Because you've got data types in there, you've got code in there. That code changes, you upgrade it, you do things to it. So now you have kind of a versioning deployment management, which is basically the whole problem when it comes to keeping your schema up to date, keeping your schema dynamic and letting this thing evolve. You need to track that versioning. And the database needs to do that natively. Right? Getting slightly more pitchy for a second, the way we do that is we model the dependency graph of all of your functions, all of your data types, and all of the implementations you use. And the database is actually aware of that. We specifically use Maven for that, and the database knows about a Maven repository, a source code and artifact repository that can pull data in when it needs to, and you can bake that into your DevOps process so that you don't ship code into this until you're ready, until it's past certain quality gates. But by doing so, you know if you have dependency conflicts, right? For those of us that write software, dependency conflicts are the thing that, like, the iteration's going pretty well, and you've got like 2 days left, and there's this bug that somebody's looking at. They don't really know why. It's like a class not found exception or something like that, incompatible class change exception, and that takes another three or 4 days when you thought it was going to be an hour, simply because you can't chase down where the dependencies collided, which is, I would say, a failure in tooling. Right? The information is there. You can sort it out, but our tooling just isn't there yet. So database needs to pay attention to this. It needs to help you solve this problem. So you can focus on delivering valuable software and not just moving software into the right place. This, I think, is a very exciting concept. It's one of the reasons I'm so excited to be working on our product. In order to do this efficiently, the other box I've got on here is this idea of intelligent query planning. I might have to get slightly academic on you here, and I apologize, right? Because I'm not an academic. But when you write a SQL statement, for those of you that have done that in a database, there's a lot of ways to get the same answer to a SQL statement. You can write one that gets an answer, and you can write one a little bit different that gets the same answer. But one of those takes 1/1000th of the total time to execute. The slight differences in SQL. The only way to debug that is to look at the query plan underneath. So that select statement is a query, and the database has to figure out what structures do I have here? What combination of indexes and tables and things like that do I have available to answer the user's question? And the smarter that query planner is, the smarter the optimizer is, the more likely you are to have an efficient running database that doesn't require hours of developer debugging to sort out. So that's a hard enough problem, but when you run it on a distributed cluster of lots of machines, the query planning exercise does get rather difficult. And this is why you find really cool things like Apache Spark out there, or now Apache Flink, which is kind of in competition with Spark, or things like Agile Data, where you know what the user wants, you know the question they want to ask, you know the logical plan they want to ask, but you don't really know, well, which server out of these 1,000 servers should I run this portion of the query on? That's a pretty fun problem. Like, so if you put on your like computer science hat and you're trying to do an optimization problem, it's actually pretty fun once you've modeled it, but the modeling is complicated and the quality gates are rather interesting. But if you want to run a distributed cluster that's doing this, that's providing you this value, you need to be able to do that kind of query planning. You need to be able to do job scheduling, obviously, because lots of people use this. Each query is effectively a job, so it needs to be a high-performance job scheduler. And then you need to be able to interface this with message queues and event streams, things that produce data for you in a streaming manner, right? So all the different message queues out there that you probably already have in use in your system, you need to be able to have adapters into something like this. And you need to be able to produce new event streams from new sources of data, just like clicks on a web page or observations flowing from sensor data. You put all this together with a set of interface tools so you can get applications can access it via ODBC or JDBC. You expose that same thing to analytics platforms so you can access ad hoc data through things like Tableau or even through other processing frameworks, something like Spark, which knows how to talk to things underneath the covers. And then you wrap that all up in a nice way to make sure it's still running and to make the ops people happy, because it's on them to keep this thing running. And you need to expose the reliability. You need to expose the performance metrics that they need to do their jobs. And the good news is there's a lot of open source tools that fit together, but this is kind of the whole picture you have to put together. I want to make sure I'm doing good on time, and I want to leave room for questions. So we've got a booth. I like talking about this stuff. It's really exciting. Right? We do have a product, right? Agile Data is the simplest way for enterprises to leverage the benefits of big data without having to become stone-cold experts in this huge swath of tools and complicated techniques. So we think this is very exciting. I wanted to end with about 10 to 15 minutes to just take questions, because I'm sure there's quite a few. And so I will do that now. Thank you, guys.